important that you have them written down because I'm not going to give them to you on a quiz or a test because you got no card. Okay? Okay? So, but yeah, you should know it. Okay? I would also like to chat a little bit about this week and next week. So, this week, we'll continue with 5.4 today. Tomorrow we'll clean up 5.4. Wednesday and Thursday we'll do 5.5, which is all about dividing polynomials. Okay. Friday of this week is a formative assessment. Okay. So I'm telling you now that there is a formative on Friday. I will tell you tomorrow that there is a formative on Friday. I will tell you on Wednesday that there is a formative on Friday, and I will tell you on Thursday that there is a formative on Friday. You have no excuse to not know when the formatives are, because I tell you a week in advance, and I remind you every day. Okay? And over on the side, on the black bin, there's a big sign that says there will be a formative assessment this week in the MRC. Okay? So you got that. Then, next week, Monday, we'll start section 5.6. Tuesday, I am not here of next week, so you guys are going to take a quiz. Okay? Yeah, I'm just that neat. Okay? And then Wednesday, we'll finish up section 5.6. Okay? It worked out. I wanted to take a quiz next week, okay? And I really wanted to take it on Wednesday, but then I'm like, hey, why don't we take it on Tuesday? That way I don't have to make a video for you. Make it easier on me. Oh, yeah. Okay. Tentatively, if you're looking ahead even further, tentatively, on the 7th of November will be the test. Okay? So, any questions then about the cubic formulas? Pretty straightforward. Okay. So, then, let us chat 2 seconds about these. Okay. 4 keys to factoring. Okay. Remember, you always check for a GCF first. Then you look to see if there's a difference of perfect squares. Then you look to see if you can factor the trinomial. Then you look and see if it's maybe a cubic plus a cubic or a cubic minus a cubic. Okay? And then today we're going to start the 5th method, which is factoring by grouping. Now, factoring by grouping only works when you have more than 3 terms. So you got to have 4 or more terms in your factoring. Okay? And you got to have an even amount of terms. Okay? So you got to have 4, 6, 8, 10, 12, 14, those even amounts of terms. Okay? All factoring by grouping is it's 3 GCFs. Okay? You're going to GCF the first half. Then you're going to GCF the second half. Then you're going to GCF what you got. And your factored part. Okay. So really it's just 3 GCFs. Okay? So, let's try it. Okay? First, I'm going to GCF the first half of my polynomial. So I'm looking at x cubed minus 7x squared. Is there a GCF in x cubed minus 7x squared? What? X squared. What's left over? X minus 7. Then I look at the second half, and I need to GCF the second half. So now I'm looking at 8x minus 56. Is there a GCF in 8x minus 56? 8. What's left over? Okay. Now, I look at the whole thing. Okay. And what shows up in both of those terms? X minus 7 shows up. So I'm going to factor out an x minus 7. What's left over? X squared plus 8. Okay. Then, now I ask myself, in x minus 7 here, nothing can be factored. In x squared plus 8, that's a perfect square, right? Is 8 a perfect square? No. So, it's not going to be the difference of perfect squares, because it fails the perfect square part, plus it fails the difference part. Okay? Is x squared a cube? No. Okay? So that's not a sum of 2 cubes. So then this is my answer. Okay. Only for me to send it away. Alright? First, I look at my first term. Or the first half, I should say, not my first term. Is there a GCF in 27t cubed plus 45t squared? Bless you. GCF in those two? 9t squared. What's left over? 3t plus 5. Okay. Looking at those last two. Is there a perfect square? No. So what can I factor out? I'm going to factor out a -1, but really I can just factor out a 1, right? But the reason I have to factor out a -1 is because that sign right there is negative. So I'm going to keep that sign, and I'm going to factor out a -1. If I factor out a -1, what's left over? 3t plus 5. And now my parentheses are the same. That's the key. That's why we need to factor out that -1, because I want my parentheses to be the same. ahead now, I GCF the whole thing. 3t plus 5 and 9t squared minus 1. 3t plus 5, is it factorable? No. 9t squared minus 1, is it factorable? Because it's a perfect square minus a perfect square, right? So this becomes 3t plus 5, 3t minus 1, 3t plus 1. You try that one. I get 2x plus 1 and x squared plus 1. The middle plus 1, because nothing goes in the green section, nothing is common. So I gotta have 1, then is the only thing that's common. Yes, ma'am. As long as you know that there's a 1 there.
And then I did 2x plus 1 and then x plus 1. Would that be considered wrong or should I just
That is wrong.
leave it as a
Well, like what did
because I have what you have, except for the x squared plus 1, I have it as x plus 1.
quantity squared?
Yeah.
Wrong.
Okay.
Because x plus 1 quantity squared is not x squared plus 1. What you're saying here is you're saying that x plus 1 squared is the same as x squared plus 1. Right? But what I'm saying is this is x plus 1 times x plus 1, which is x squared plus 2x plus 1, which is not that. So no on, yes on the first one, no on the second one. Because it's not, it is perfect square and a perfect square, but it's not a difference. Yep, it's got to be a subtraction sign. Okay? So, where are we going with all this? Well, now that we've refreshed our factoring, we're going to solve now. We're going to solve by factoring. Okay? So, what I need to talk a little bit about is the fundamental theorem of algebra. The fundamental theorem of algebra states that the degree of a polynomial equation, what's the degree again? That's the first exponent, the biggest exponent. Okay? So the biggest exponent is going to tell me how many solutions, real and complex, I get in an equation. So this first example, how many solutions should I get? I should get 5 solutions because the degree is 5. Okay? Now, today and tomorrow, we're only going to look for the real solutions. We're not going to look for those complex solutions. We're only looking for real ones. But just remember that complex solutions come in pairs. Okay? Got to come in pairs. Complexes do. So if we have 5 possible solutions, we could have 5 answers for this problem. We could have 3 answers for this problem. Or we could have 1 answer for this problem. Okay? Because those complexes come in doubles, or come in pairs. Okay? Alright? So, we need to find real solutions. So, the first thing that we have to do is we have to get our equation equal to 0. So, the first thing that I would do here in this one is I would add 36x to both sides. If I add 36x to both sides, that gives me 4x to the 5th minus 40x cubed plus 36x equals 0. Then my second step is going to be that I need to factor completely. So I need to factor the left side of this equation completely. Where do we start? Is there a GCF? For x? Huh? What's left over then? X to the 4th minus 10x squared plus 9. Are we factored completely? No? Okay. So what do you want to do next? Can anything factor out of 4x? Nope, so that's going to stick there. Can I factor what's inside the parentheses? Probably. Okay. What times what gives me x to the 4th? X squared and x squared. Two numbers that multiply together to be positive 9 and add to be negative 1. Or excuse me, negative 10. Negative 9 and negative 1. Okay? Am I factored completely? Why not? Perfect square minus a perfect square in the here and there. Okay? So this one's really going to get big now. Yes, am I factored completely? Now I am factored completely. Okay? So now, step 3 says, set my factors equal to 0 and solve them. Okay, so 4x equals 0, x minus 3 equals 0, x plus 3 equals 0, x minus 1 equals 0, x plus 1 equals 0. Okay? Now I got to solve those. So on this one, I would divide by 4, giving me x equals 0. On this one, I'd add 3 to both sides, giving me x equals 3. On this one, I'd subtract 3 from both sides, giving me x equals negative 3. On this one, I'd add 1, giving me x equals 1. On this one, I'd subtract 1, giving me x equals negative 1. Okay. So my answers then would be negative 3, negative 1, 0, 1, and 3. Yes, ma'am.
Would you be able to write it as like plus or minus 3 or plus or minus 1?
In some order like that?
Yeah.
Yeah. Okay. Ready to try one on your own? Go for it. How many answers should I get? 4. Or maximum number would be 4. Okay? So first, I would add 3x squared. That gives me x to the 4th plus 3x squared minus 10 equals 0. Then I would factor that. X squared plus 5 and x squared minus 2. Agree with that? Okay. Then x squared plus 5 equals 0. X squared minus 2 equals 0. X squared equals 2, so x equals plus or minus the square root of 2. X squared equals negative 5, so x equals plus or minus I times the square root of 5. Do I like I times the square root of 5? For an answer under these directions? Why not? Not real. They're imaginary. Okay? So those go away, leaving me with just plus and minus the square root of 2 as my answers. Okay? Questions on that one? Try that one. So, this one's got 4 terms, so I'm automatically thinking grouping. So I'm going to factor out an x squared. That's going to leave me with an x plus 3. Then I'm going to factor out a 5. And that's going to leave me with an x plus 3. Then I'm going to factor out an x plus 3, and that's going to leave me with x squared plus 5. X squared plus 5 doesn't factor any further, so that is my factored completely step. X plus 3 then equals 0, and x squared plus 5 then equals 0. So I get negative 3 for the first one. X squared equals negative 5, so x equals plus or minus I times the square root of 5 there. But I don't like that one because it's imaginary. So only negative 3 is my answer. Okay. Questions on that one? Thursday, I gave you the option of homework, no homework. So, and you chose Monday for homework. So here is the 5.4 homework, and it will be due on Wednesday.